Okay, hello everybody. We're now going to finish up 1.7 and move on to section 1.8. 1.7 is doing what we just did a couple lessons ago with composite functions, but now we're going to use composite functions to verify or prove if two functions are inverses of each other. So if you notice here it says you can check if two functions are inverses by finding both of their composite functions. F of x and g of x are inverses if and only if f of g of x simplifies down to x and g of f of x simplifies down to x. So if you remember what we did the other day, basically we're going to plug 2x minus 8 in for x right here. So we're going to say g of x equals 1/2 2x minus 8 plus 4. So distribute the 1/2 and we get x minus 4 plus 4. Join like terms and we get g of x equals x. Now we're going to do the same thing, except now we're going to take g of x and plug it in for x over here in the f function, f of x. So f of x equals 2, parentheses, plug in the 1/2 x plus 4 minus 8. Distribute the 2. 2 times 1/2 is 1x plus 8 minus 8. Join like terms, and once again, what do we have? F of x equals just x. Very key. Both have to equal x. If both are equal to x, you know that these two functions are inverses of each other. Now remember, we could do the other process where we take y equals 2x minus 8, switch the x and the y, and do that. And we could do the same thing with 1/2 x plus 4. But this is a very quick way to test if these two are inverses of one another. So we're going to do the same thing here. We're going to take 2x squared minus 1 and plug it in right there for x. So g of x equals the square root of 2x squared minus 1 plus 1 over 2. So g of x equals the square root minus 1 plus 1 simplifies of 2x squared over 2. 2's cancel. G of x equals the square root of x squared. And the square root of x squared is simply x. So that side works out. Now we're going to take this one and plug it in right here. So f of x equals 2, parentheses, x plus 1 divided by 2 squared minus 1. Well, remember, when you square a radical, it goes away. So you end up with 2 times x plus 1 over 2 minus 1. 2's cancel, leaving you x plus 1 minus 1, which leads you down to f of x equals, once again, simply x. And you have proven now that these two functions are inverses of one another. That's the end of 1.7. Moving on to 1.8. Simplifying radical equations. So our goal is to solve simple radical equations, including those with extraneous solutions. So a radical equation contains one or more radical expressions, something with a square root or cube root symbol. So here's what you do. First of all, you want to get the radical alone. So here's my radical, square root of x minus 4. There's a plus 2 attached to it. So how do we get rid of that? We subtract it, leaving me radical x plus 4 equals 7. Now, take both sides to the power that matches the index of the radical. Now remember, we just know this is a square root. We don't normally write a 2 here. But it's very important to realize that's a 2, because what we're going to do to cancel the square root is to square that entire side. Now what we do to one side, we must do to the other. So squaring cancels the radical, and we're left with x plus 4 equals 49. Now we solve for the variable, step 3, x equals 45. Now, since I don't make mistakes and I just throw things in there for you to catch, what did I do wrong here? I know I made a mistake because I checked my answer, 45. 45 minus 4 is 41, and the square root of 41 plus 2 is not 9. The square root of 41 is a decimal, in fact, and I need to be 7, which means I need this radical to be 49. So I made a mistake. What is it? Well, you haven't seen it. This should have been x minus 4. I had a copy error, which happens, which means I should add 4 to both sides. And my answer here should be 53. Now, if I check my answer, and once again, this is a very valuable lesson because I make mistakes too, and this is how I know. Check your answer, plug 53 back in. 53 minus 4 is 49. The square root of 49 is 7, and 7 plus 2 is 9. So it does help, no matter what level you're at, to check your answers. Now, it says here, when solving radical equations, it's very important to check for extraneous solutions. Nice big fancy math word. It simply means these are numbers that look like solutions, but do not work to make the original equation true. So, as you can see, I would have to plug my number in anyway to test for extraneous solutions, but also to check for any errors, which I made, clearly. So, let's go to example 2. 2 plus 4x to the 1/2 power equals 0. So here we go. I want to subtract 2 from both sides. That is going to give me 4x to the 1/2 equals -2. Now I divide by 4. That gives me x to the 1/2 equals -1/2. Now remember, x to the 1/2, anything to the 1/2 is really the square root of x. So what do? To get it by itself, I'm going to square both sides. Which leads me to the answer, x equals 1/4. Which I want to plug back in for my x right there. So first off, I'm going to take 1/4 to the 1/2 power, which means the square root of 1/4. So what times itself is 1/4? Well, we've kind of proven above. 1/2 times 1/2 equals 1/4. So 1/4 to 1/2 hot power is 1/2. And then 1/2 of 4 is 2, and 2 plus 2 is 4. So that would give me, after plugging my number in, 4 equals 0. And so since 4 does not equal 0, example 2 is an example of an extraneous solution. Okay, so the cube root of 4y minus 1 minus 2 equals 1. Next step there is to add 2 to both sides. That gives me the cube root of 4y minus 1 equals 3. Since this is a cube root, I'm going to cube both sides. That cancels my radical, leaving me 4y minus 1 equals, sorry, not 9, that's 3 squared, 27. 3 times 3 times 3. Add 1 to both sides. I'm running out of room, so I'm not going to show all this. Add 1 to both sides. It gives me 4y equals 28. Divide by 4, I get y equals 7. If I plug that back in, 7 times 4 is 28. 28 minus 1 is 27. The cube root of 27 is 3. And 3 minus 2 is 1. This one checks out. It is a solution. 7 is our answer. Okay, over here, I personally am going to rewrite this as the cube root of 3x plus 1. You don't have to, but I am. I'm going to subtract 5 from both sides, giving me cube root 3x plus 1 equals 2. Just like the previous problem, I'm going to cube both sides, which leaves me with 3x plus 1 equals 8. 2 times 2 times 2. Let's subtract 1. You get 3x equals 7. Divide by 3 and I get the fraction answer. Yes, fractions are our friends. 7/3. I'm going to plug 7/3 back in up here for x. Looks scarier than it is. 7/3 times 3 is just simply 7. 7 plus 1 is 8. The cube root of 8 is 2, so we get 2 equals 2. Or, if I plugged it in up here, 7/3 of 3 once again is 7, plus 1 is 8. Cube root, or 8 to the 1/3 is 2. 2 plus 5 is 7. Checks out. So once again, 7/3 is our solution. For example 5, it says if both sides contain a radical expression, either square both sides for square roots or cube for cube roots. So if I square both sides, I end up with 2x plus 5 equals x minus 12. Subtract x from both sides, subtract 5 from both sides, and I get x equals negative 17. Okay, so we're almost done. We have to plug the negative 17 in, and when we do that, we're going to get the square root of 2 times negative 17 is negative 34, plus 5 is the square root of negative 29, equals negative 17 minus 12, negative 29. Now, although they are both the same, there's no solution because we can't take the square root of a negative number. Now for this one, the last one, we're going to cube both sides. When we do that, we get 5x minus 2 equals 2x plus 13. If I add 2 to both sides and subtract 2x, I end up with 3x equals 15, x equals 5. If I plug them both in, I end up with the cube root of 23 equals the cube root of 23. Check. So we're done. So this one would also be an extraneous solution because there is no solution at this point. Example 6 checks out, so we're good. Have a good night.